Hello everyone, I am Ananya from G330 and today I'll be talking about my project that is Joyverse. Joyverse is a platform where dyslexic children play games that adapt in real time based on their emotions and performance. Therapists can monitor their progress and offer personalized support throughout the learning process. There are a lot of things that I've learned during my project implementation. So let me list out a few. Firstly, I've understood how to dynamically change the game elements or the application elements so that the user's experience feels more alive and responsive. And we have done this dynamic updation based on the emotion predicted from the user and also the user's performance. Nextly, I've understood how to integrate all the components together to make them all work and function smoothly for a smooth user experience. And nextly, I've understood how to use Face Mesh. Face Mesh is actually part of Google's MediaPipe framework, which actually maps 468 facial landmarks on your face. So we use these facial landmarks to predict our emotion labels. Nextly, I've learned how to integrate the model and also the project. So we have actually built our transformer from scratch. So we use Flask API to communicate with our project. So integration of this all is what something I've learned newly. And next, coming to security and privacy. So I've understood how to have authorized users so that not anyone and everyone can access the website and it is actually used by the people who it is intended for. So the changes made are firstly we introduced a super admin user. Before anybody could sign up as a therapist and use our dashboard, but right now super admin registers the therapist and then gives those credentials to the therapist. Nextly we added secure access for children. So anybody could sign up as a child and play our game. But right now we have added a feature such that the therapist can add a child or add his own client under his name. And next we have also stored each child's game progress by session. So every time a child logs in and plays the game, it is recorded as a new game session. Coming to the challenges, firstly, coordinating emotion and performance. From the very beginning, we had a very clear idea that we would change the themes based on the emotion and the difficulty levels based on the user's performance and score. So, having to come up with a logic that fit both of them well and also having to actually implement it into code was quite challenging for us. Nextly, finding the right data set. Since our project mainly focuses on children, we had to find a children emotional data, which we did. So all the teams in our project group, contributed 50 images per emotion and formed a collaborative data set, which also didn't work quite well for us. So then we shifted to FER dataset, which is right now giving a good accuracy. Nextly, unbalanced data issues. So the data set was very uneven. Like one emotion had a lot of samples and the other emotion had a very few samples. So we had to make it balanced for training our model. Nextly, integration challenges. So when we had to integrate all of the components, like different people worked on different components. So integrating all of them was very challenging because when you add one feature, the old features keep giving new issues. So fixing all of them was very time consuming and effort taking also. So we did careful testing and adjustments to make the game experience very smooth and uninterrupted. Nextly, UI interruptions. We also had very unexpected and unnecessary interface reloads because of some issue somewhere. So we carefully managed the state and prevented those reloads so that our gameplay was smooth. And lastly, the emotion model accuracy. Because of various reasons like limited and unbalanced data, even with face mesh, we struggled a lot to improve our emotion model's accuracy. Now, the reasons for building a transformer model. First of all, a transformer is very effective in capturing complex relationships between the features. That is why we chose a transformer because it effectively captures the complex relationships between the facial landmarks which are extracted using face mesh. Nextly, the data we are processing in our model is not sequential. That is why we chose a transformer because it is very well suited for spatial data like facial landmarks, where position and geometry matter more than just simple sequence. It also effectively models inter-feature dependencies, which are critical and important for accurate emotion recognition. Nextly, we are making use of face mesh because it is lightweight. Because when processing images and making predictions on it is a very heavy process. That is why we are quickly extracting facial landmarks using face mesh and making it lightweight emotion tracking. Nextly, we are also making use of Face API to enhance our emotion prediction by combining its built in models with our landmark based approach. The other models that we consider are the following. Firstly, pre-trained emotion models. So there are a lot of emotion prediction models available in the market, like models from Hugging Face and Deep. These typically use raw images, which raise privacy concerns because we are actually storing the user's images in our databases. And also, processing images is very heavy and resource intensive when compared to processing facial landmarks. Also, if we had to fine tune these models to have facial landmarks as input, it would require very extensive fine tuning. And also coming to support vector machines, that is SVM models, we initially made use of SVM model to predict our emotions using facial landmarks. So this was very simple and fast, but it was unable to capture complex spatial relationships in these landmarks. So it was having a very limited accuracy. That is why we switched to transformers. For deployment, we can deploy our front end on Vercel, the back end on Render, the AI model in Hugging Face basis, and for database, we can use MongoDB Atlas. These are the most important code snippets from our project. So this is an API endpoint in server.js which receives the landmarks from the front end and sends them to the model, which then gives back an emotion, which is then returned back to the front end again. Now this is another endpoint which returns the most frequent recorded emotion for the current puzzle. So our emotion is predicted every 5 seconds. So during one current puzzle, so how many ever emotions are detected, amongst them the most frequent emotion is taken, and this is considered as an emotion for that particular puzzle. So that is what is returned by this API endpoint. Now this is the Flask API in our backend, that is the model that predicts emotion from facial landmarks using a PyTorch model. Nextly, this is the detect face mesh function, which continuously detects facial landmarks from the webcam video and draws them on a canvas. This is present in our game component. Nextly, this is also present in our game component, which is useful for adjusting themes and difficulty levels. So the logic is very simple. We are changing the theme based on the emotion and the difficulty level based on the score. So if the last two answers are correct, we move on to the next level. If both are wrong, we move on to the previous level. And if at all there are negative emotions like fear, anger, or disgust are detected, then we switch the theme. If the positive emotions are detected like happy and neutral, we stay in the same theme. And lastly, this is an API endpoint which is useful for registering therapists. So this is present in the super admin dashboard. So now I will show the demo of the project. This is our homepage. It has different sections like about us, FAQ, feedback, etc. So this is like any homepage of any typical website. Now we are moving to the super admin dashboard. So first we go to the login page where we enter the super admin credentials. And then we are directed to the dashboard where we can register therapists. I already have a therapist named Ananya. Now I'm logging out. And now I'm moving back to my homepage. So here I see a get started button where I'm directed to the login page. Now this is common for therapists and children. I'm logging with Ananya account. So now I'm adding a user, child user, that is Anu. I'm assigning themes. Maximum I can assign 3 themes. So I'm saving them. And then this is the unique therapist code which is given to the users, child users of that particular therapist. Now I'm logging in with the username, child username, and the code which I've copied earlier. And now the game will not start until all the models are loaded. Now the game is loaded. Now this is a typical game where you have to select the word, the correct word which is given in the picture. So I'm selecting them. Now I'm ascending to the next levels, and I've given the correct answer. And if the last two answers are wrong, then only I'm demoted to the previous level. And I'm changing it to the face mesh. I've used face mesh earlier, now I'm using face API. And now let's see the console. So here if you see the last two answers are given, and also if you notice when anger is there, the theme change is happening, and happiness, no, we stay in the same theme. And we are exiting the game. So since I've played 6 games, I've got 6 score. And now I'm switching back to the therapist account so that I can view the emotional summary. So for the child Anu, this is the session history. And then for the summary, emotion summary, and that's it. And that is all. Thank you.